Functions is one of the base for the whole calculus. So we'll be studying functions today. Topics which will be covered in this are introduction and definition of functions, rules to define functions, representation of a function, finding values of function, piecewise defined functions, and application based on functional notation. So first of all, what is function? The basic definition is function gives you the connectivity between elements of two different sets. Sets can be same also, but right now in the basic criteria we are assuming the sets are different. One is set x, another is set y, and function will be defined from x to y if function is a rule that assigns each element small x of a capital set X to a unique element small y of the other set capital Y. We denote elements by small letters and sets by capital letters. So the element small y is called image of x under f and is denoted by f of x. We generally write it as y is equal to f of x. So in representation, suppose there are two sets x and y. The first set x is called domain and the set y is called codomain, and there is a subset of codomain which is called range that will contain the images of elements of set x. There can be other elements also which didn't get connected with set x in codomain. So this criteria by which the elements are being connected this criteria is called a function. So here the set x is called domain of f and the set of all images of elements of x is called range of function. Collection of elements in y which got pre-images in x means which got connected from the set x is called range, and the whole set y is called codomain. We'll study about them in detail later on. Right now this is the basic definition of function, and function here is defined from x to y. So there are a few rules to define functions which we need to keep in mind before defining it. First of all, the first rule is for each input function assigns a unique output. There should be a unique output whenever we substitute the value of x in function. Suppose here the function is x square plus 1. If I'll give a certain input, suppose x is equals to 1, I'm substituting here. So I'll be getting 1 square plus 1 as 2, which is the output, and this output is unique, means I'm getting the single value, unique value. I'm not getting more than one value. So this is the first rule. For each input we must have a unique output, and the only condition here is the input should be a legitimate value. Legitimate value means the value should be as per the law, as per the domain of function, means it should be a valid value. You cannot take any value as input, right? It should belong to the domain of the function. How to find domain of the function we'll discuss. So for example, in reals, every calculus function we discuss in throughout the calculus is based on the context of real numbers only. So that is why I'm writing in real numbers. -1 is not the legitimate value for the function fx is equals to root x, because square root is not defined for negative values in case of real numbers. In case of real numbers you cannot take negative value for the square root, right? So -1 is not here the valid value for this function. So for every function this is different. The second rule states that two different elements in domain can have same image in set Y. In fact, not just the two different elements, more than two elements can also have the same image. And if this is the criteria of defined function, the function would be called many one function. So this is one of the type of the function. See, more than one elements are connected to one single element in set Y. And if it's not like that, every element is getting connected with one element, then it is called one function, or you can say one-to-one function. The above one is the case of many one function, where more than one element is connected with the same element in Y. So in this rule we can say further, if each element in range is the image of one and only one element in the domain, then f is called one-to-one function. Then f will be one-to-one function, means every one element is connected with one element. See, reverse cannot be even possible. You cannot think of the reverse, means more than one element in Y can't have the same pre-image in X, right? So this also you should remember. The next rule is, it is possible for Y to include elements which are not in the range of F. Means Y can have elements which didn't get connected with any of the element of X. Y can have elements. In this case, codomain and range would be different, where there are few elements left out in Y which didn't get connected with X. And whenever there is no element in Y which is left out, means there is no element in the set Y which didn't get connected with any element of X, then the function is onto. Means in that case your codomain and range are same. X can't have elements which can't have any image. So this also you need to remember. There cannot be any left out element in X, right? So I am also giving you the criteria of negation statement also. There can be left out element in Y, but there can't be left out element in X. This also a rule. So when there is no left out element in Y, codomain is equal to range. In that case, function will be called onto function. Next is about the bounded function. A function f is said to be bounded on interval AB, A to B closed interval, if there exists a number, a real number k, such that mod of fx less than equal to k for all x belongings to the interval AB. Means for every element from the interval you take, the value of the function is lying between minus k to k, then function is bounded. So next is about the representations of function, how we write, how we define these terms. So y is equals to fx is the notation of a function where x denotes the input and y denotes the corresponding output. Means we substitute the value of x and we get y as the answer. Both x and y here are called variables, and since value of y is depending upon x, means we first substitute x and then we get y. So y is determined by x, so y will be called dependent variable. And since x is free from anything, x is not depending on anything, we are giving the values of x, so x is called independent variable. And when we write fx is equals to x square plus 1. Suppose this is a function I'm taking. If I'm writing fx is equals to x square plus 1, by this what we mean? We mean the function f is a collection of all ordered pairs, x comma y, the coordinate pairs, satisfying the equation y is equals to x square plus 1. Means y is equals to fx here, so equation must be satisfied by xy point is y is equals to x square plus 1. So next is how we find values of the function. This is very easy part. Suppose function is given to us, let fx is equals to 2x square minus x, and we need to find the values f of minus 1, f of pi, and f of x plus h minus fx upon h. H here is non-zero, x and h are real numbers. So this is simple substitution in place of x. F of minus 1 means substitute x is equals to minus 1 in the function and get the value of y. So in this case it's 3. F of pi will be 2 pi square minus pi. F of x plus h minus fx upon h is the substituting x plus h in place of x in the function first. So f of x plus h will be 2 of x plus h whole square minus x plus h minus fx as it is upon h. So after simplifying, we can see h can be taken out from the numerator and be cancelled out from the denominator. But we can do this because h is non-zero. Only non-zero values get cancelled out, right? So this is the answer. Next topic is what are piecewise defined functions. So there are some functions which are not representable as a single formula. They are given us in the parts. Specific values partitions is given to us. Certain functions that are defined differently on different parts of their domain and thus expressed in terms of more than one formula. There will be more than one formula for the functions in parts. So these are called piecewise defined functions. For example, evaluating a piecewise defined functions here means I'm giving you the example and finding the value for the same for specific terms. Suppose fx is equal to given as minus 2x plus 4 for x less than equal to 1 and x plus 1 for x greater than 1. And we need to evaluate f of 3, f of 1 and f of 0 over here. So f of 3, you just need to check which formula you need to use. F of 3 means x is greater than 1 for 3. So we'll be using x plus 1 as formula and substituting x is equals to 3. Similarly for f of 1, we'll be using the function where x is equals to 1 given, the first part, and f of 0 is the value where x is less than 1. So I'll be using minus 2x plus 4 for substitution, right? So this is piecewise and how to evaluate in that. Next is we are discussing there are some statement questions which are basically the application of functions, or you can say functional notations. So the questions are of this kind are in terms of a statements. For example, here the total cost in rupees of manufacturing Q units of a certain commodity is given to us in the form of formula, in the form of a function C of Q. Q is the units over here for the commodity. So C of Q is given to us in the form of formula, and we need to compute cost of manufacturing 20 units in A part, and in B part compute cost of manufacturing 20th unit. 20th unit manufacturing cost. So to calculate this, we just need to substitute certain values. If you want cost of manufacturing 20 units, you need to find simply C20, means substitute 20 in place of Q and get the answer. So this is very simple. You can easily calculate. After simplifying, 8,000 minus 12,000 plus 8,000 plus 500 will give us 4,500. So this will be the amount of 20 units manufacturing cost. And the second one is when it's asking 20th unit cost. So for this you need to find C20 minus C19. Subtract the cost of 19 units from the cost of 20 units will provide you cost of 20th unit.